So this first section on the deltamath, converting radians to degrees. What do I want to do here? So I have convert the angle -3 radians to degrees, rounding to the nearest tenth. So if I'm going to radians to degrees, what's the conversion factor I need to multiply by?
180 over pi.
180 over pi. So I'm literally going to take my calculator and multiply -3 by 180 over pi. What is the answer, or what does the directions tell us to round this to?
The 10, the 0.9.
To the nearest tenth. So that should be 171.9, was that right? Let me pull that back up, my memory's not that good, yes. -171.9. And it's good. Everybody feel okay on this? If we go degrees to radians, what's my conversion factor?
Pi over 180.
Pi over 180. Note, what does the direction say though? Enter answer in simplest form, right? So that means that it wants a fraction in terms of pi. So easiest way to do this, if I'm using my calculator, is I'm going to do alpha y equals command 1. I'll write 285 over 360. And then I'm going to tack a pi onto that fraction. Bye.
Bye.
Say hi to your counselor.
Hello.
Thanks. So I would write 19 pi over 24. Does everybody feel good? Again, I'm kind of bulldozing these guys as they should be a little bit easier. Hi, Emerson. You looking for some? Oh, you need that.
I know, that's okay.
Okay, well, good luck. I hope it turns up. They're expensive. Oh no, what did we do wrong?
You put pi.
Well, I should.
Oh.
Oh my gosh. When you said the conversion factor, you said pi over 180. When I typed in my calculator, what did I type in? Did I do 180?
Over 360.
I did 360. Ugh. Let's try that one more time. No, that's not what I told you to do. So let's try 19 pi over 12, eh? There we go. Sheesh!
Alright,
So far, so good?
what
Okay.
is the fraction we get for the making?
So here, it's asking us to do a, find the third side of a right triangle. To do that, we're going to use?
SOHCAHTOA.
No.
Pythagorean theorem.
Pythagorean theorem, right? We can't do SOHCAHTOA if we don't have angles. I mean, I guess we can, but we solving for an angle and then going and doing another SOHCAHTOA. Or I can just Pythagorean theorem it one shot. Let's do that instead. So if I do that,
Want to look at the other thing to make it and put it under.
what sides are my A and my B, right? My Pythagorean theorem says A squared plus B squared equals C squared. What sides are my A and B? Actually, let's just say which side is the C. That's easy.
Hypotenuse.
Right, so which numbers is that? Or is it the blank?
The two Square root 41.
Good. 2 square root 41. So we're going to have a squared plus, I forget what the number is, and then 2 square root 41 squared, right? Remember what, oh, that's not the thing I wanted. I wanted this one. 8 was the other one. Everybody's okay with the setup so far? Yes or no? Okay. What's 8 squared? 64. How do I do 2 square root 41 squared?
Square the 2 and the square root comes out.
Okay, you square the 2, and then when you square the when you square the root 41, the square cancels the square root. Or what else could you do? Type it into the calculator exactly as it's written with the parentheses. You get the same route or result. I think it's 164. You can double check that for me if you like, but I'm pretty confident. Then to solve for a, we subtract 64 from both sides, so a squared is equal to 100, right? To get the a, get rid of the a squared, you just want the a. What do you do to both sides? Square root. When we square root both sides, what does that create? Well, creates a plus or minus. And because this is the side length of a triangle, which answer makes sense? Only the plus, right? Negative side lengths are goobly-gook. So we think of this answer just as 10 here. Everybody feel okay doing Pythagorean theorem stuff? Again, you probably have to write out a little bit of work there. That's okay. You don't have to turn any of the work in that you write out. Just, do it on scratch paper, whatever. It's fine. I don't need to see it. Okay, the next one says, this is about identifying trig ratios from a diagram. So here we're asked to find tangent of y in simplest radical form. So notice I have a right triangle. You can tell because there's a little corner thing in there, right? So we're just going to use SOHCAHTOA. So the first thing I do is I find where y is on my triangle. It's that angle here. So tangent, I remember, is opposite over adjacent. Which side is opposite relative to the y?
10.
10. Which side is adjacent?
96.
Square root 96. And it wants simplest radical form, so I'm going to have to simplify that. So we're going to have 10 over root 96. Now, root 96 is not, or 96 is not a perfect square, right? If it was, I could just square root it and be done with it, and you could reduce the fraction or something. And I could rationalize the denominator to start, but it's going to be more work, or more cleanup at the end anyway. What I'm going to start with is just simplifying that radical, right? So if I look at 96, I want to break that apart into simplest radical form first, and then we'll rationalize. How do I break apart square root 96? I'm going to start by just kind of drawing the prime factorization, the factor tree for the number 96. Everybody's good with that? Because I don't see the perfect squares that go into that right away, maybe. So 96 is even, right? So what number do we know divides it?
2.
2. 96 divided by 2 is 48. That's not a perfect square though, right? So we'll keep going. 48 is 2 and 24. Now here I see a perfect square for 24, right? 24 is what times what, where one of them's a perfect square?
4 and 6.
4 times 6. Oops. And now I don't care about the prime factorization on that one. So now if it's square root 96, I can do the same thing. I just put pop square roots on top of everything. Everybody okay? So square root 4, that's just a regular 2. Square root 2 times square root 2, that's a regular 2. Square root 6, I can't do anything better with that because that's root 2 times root 3. Everybody's good? So this is going to simplify to 2 times root 6, or 4 root 6.
Wait, why wouldn't it be 2 root 6?
Well, I have 2 times 2 times root 6. Gotta make sure I get them all, right? Everybody's good? Okay. Notice I can reduce the fraction here a little bit. Let's do that before we rationalize, might as well. The 10 over 4. So I can do that. Everybody happy? And now let's do our radical, or rationalize our denominator anyway. Because remember, root 6 times root 6 is just 6. So that's where the 12 comes from, the 2 times 6. How's that feel? It was a little bit of work, right? I definitely would have to write this down. I'm not going to do that in my head, because the computation is tedious, a little bit. I can't do it on my calculator because the deltamath is asking me for an exact answer, so I need to do it by hand because I need the radicals in there. The calculator can't do that for me. But 5 root 6 over 12, that's what I'm looking for in the end. So 5 root 6 over 12. And
Yeah, you need to do it under 100 seconds.
Under 100 seconds? What, is that like a minute and a half?
1 minute and 40 seconds is 100 seconds. So the next one is just asking us to identify trig ratios. Wants us to do 10 in a row, correct, within 100 seconds. So basically you take 10 seconds a question.
So probably 10.
So tan of A, opposite over adjacent, so 6 over 8.
Also get 0.
Cosine B, adjacent over hypotenuse, 36 over 39. Sine of A, opposite over hypotenuse, 24 over 30. Sine of B, opposite over hypotenuse, 25 over 65.
But the rest of them?
Cosine B, adjacent over hypotenuse, 12 over 13. Cosine A, adjacent over hypotenuse, 57 over 95. Sine B, opposite over hypotenuse, 30 over 78. Tan of A, opposite over adjacent, 32 over 24. Tan B, opposite over adjacent, 13 over 84. There.
We have a new.
You just crank away. If you get one wrong, it makes you restart. If you exceed 100 seconds, it makes you restart. One question every 10 seconds should be pretty doable when all you have to do is like opposite over adjacent or adjacent over hypotenuse or opposite over adjacent, right? Again, you're going to feel like you want to rush. Don't. You have 10 seconds to identify which one it is. You don't have to do any calculation. You don't have to simplify and give the simplest form, right? It's just multiple choice. You're going to want to rush. Don't. Just go slow and double check things, make sure you're looking at the right angle, make sure you've got opposite, adjacent, or hypotenuse, or whatever identified. It'll be okay, it may take you more than one try, that's okay, there's no penalty for having to do it more than once. Everybody okay? Again, now it's asking to find trig ratios with radicals, so it's asking for sine of A. So A is opposite over hypotenuse, root 84 over 10, but it asks for it in simplest radical form. My question is the square root of 84, is that as simple as we can do? Doesn't seem like it, right? Hopefully you can look at that and go, well, I know 84 is divisible by 4, right? Because 8 is divisible by 4 and 4 is divisible by 4, it's just a 2-digit number. So I would just start by just doing a quick breakdown. Root 4 is just 2. 21 is 7 times 3. Those are both primes. That's as simple as I can do for square root 21 is just square root 21. So again, like I'll write something down here just to make sure, but I'm going to have 2 root 21 over, 10. What's the problem though with what I just wrote? Two root 21 over 10. It's going to spit this back at me and say, nope. Not the root, the fraction.
Oh.
Right? 2 over 10 can simplify. So like, if it barks at you like that's not the right answer, you're like, the heck, that's not the right answer. Just make sure you did fully simplified things. Yes, of course.
Is this all of it?
Identifying reciprocal trig ratios, timed.
Yeah.
It's the same idea as the timed one, but now instead of sine, cosine, tangent, you're going to look at cosecant, secant, and cotangent. So cosecant is hypotenuse over opposite. So hypotenuse over opposite, 85 over 36. Cosecant, hypotenuse over opposite, 58 over 40. Cosecant, hypotenuse over opposite, 80 over 48, and so on and so forth. I'm just going to stop this and not grind through the whole thing for you. And your last is going to ask you to just find the exact value for the trig ratio, right, in simplest form. But now all the trig ratios are active. So you could be sine, cosine, tangent, secant, cosecant, cotangent. But it's the same idea as what you did here. It just won't be limited to only sine, cosine, and tangent. The other ones will be good. You guys feel okay with the delta math, what it's going to be asking you to do?
Yeah.
Okay, everybody has stuff to work on, math-wise? Okay, I'm going to shut up and let you guys be productive. Sound good?
Yeah.
Okay, so whatever you feel like is the highest priority thing for you, hit it. Whether it's the homeworks, whether it's the delta math, whatever you feel like that's what I want to work on right now. I'm going to leave that up to you and not micromanage that. Okay? Just be productive. Find some math. If you need a calculator, I have a stack on my desk. You're welcome to borrow them.